Assalamu alaikum. In this video, we will discuss Millikan's oil drop experiment to determine the charge of an electron. For this, he used a chamber provided with a glass window. Glass windows, and the chamber appears something like this. This is the chamber. As I told you earlier, this chamber is provided with the glass windows. The glass windows were present here. One glass window here, another glass window just opposite to it. Okay, and inside this, two metal discs were placed. These metal discs were of the diameter of 20 centimeter and separated by a small distance of 1.5 centimeter. The upper disc is provided with a small hole at the center. Okay, just above this small hole, the mouth of an atomizer was placed. This is the atomizer. The mouth of this atomizer was placed. The nozzle of this atomizer was placed just above this hole. And it comes from outside. This is the atomizer. It is filled with the oil or glycerin. Now, what is the use of this? Now, when we say atomizer, it is nothing but a sprayer. With the help of this atomizer, we can drop oil or glycerin inside the space provided between these two metal discs. And here, these metal discs were attached to a power supply which is capable of producing a voltage of around 10,000 volt. So this disc, the upper disc was connected to positive terminal of the power supply, and the lower disc was connected to the negative terminal of the power supply. And the potential difference between these two discs is nothing but 10 kilovolt. That means 10,000 volt. Okay. And here, through this window, light is passed inside the chamber. The chamber is completely dark from inside, so nothing is visible from outside. So in order to have a clear view, we pass light from this window, and through this window, we observe the movement of droplet. Suppose I press the atomizer, then it releases few drops. These drops starts moving downward. Okay, in this way from the nozzle. Clear? It can be observed with the help of a microscope. This is the microscope which is used to observe the movement of the droplet. Here, one can have the magnified image of the droplet of this of the oil or paraffin or glycerin, whatever is dropped inside. Okay, and here to charge these drops, the X-ray is passed inside the chamber through another window. Clear? We know X-ray is nothing but an ionizing radiation. Whenever it is passes through something, it charges that object. Okay, so by passing X-ray inside this chamber, the drops occur charges. Okay, and they get attracted by the electric field. No? here when this is connected to positive terminal and it is connected to negative terminal, here we find that an electric field is generated. This electric field passes from positive terminal towards the negative terminal. This is the electric field, represents letter E. Okay. So in the presence of electric field, the charged droplets experiences electric force, and as a result they can be made to move upward, or they can be made to move downward, or even they can be stopped at one particular place such that they can be viewed with the help of microscope. Clear? This is all about the experimental setup. Now we'll get into the method. Now we'll find out the charge acquired by these droplets. Now before doing so, I am going to find out the radius of these droplets. Okay. Now before going to get the expression for the radius of a droplet, let me provide some more information. Let me tell you what are the different forces acting on these droplets. Here, the droplets, when they are dropped from atomizer, they move freely when there is no electric field. There is no electric field, the droplets move only under the action of gravitational force, and we call this as a free fall. They fall freely in the downward direction due to gravitational force. Now when we apply electric field along with the gravitational force, the droplets also experiences electric force. So there are two forces are experienced by this droplet. Apart from this chamber is filled with air, so they experiences a air drag, as a result of which buoyant force is experienced by this droplet. And apart from this, they experiences one more force. That force is nothing but viscous force. Okay, so I can say the droplet experiences four types of forces. One is gravitational force. This gravitational force. The gravitational force is the product of mass and acceleration due to gravity. Okay, and the second force experienced by the droplet is nothing but buoyant force, represents letter FB. And the third force is the electric force. It is due to the electric field between the disks. Okay, here electric force is obtained by multiplying electric field with the charge present in the droplet. And the fourth force is nothing but viscous force. Viscous force FV. Okay, these are the forces experienced by the droplet, oil drop. Now, let me draw the free body diagram. First, when there is no electric field, in the absence of electric field, drop experiences gravitational force and gravitational force, buoyant force and viscous force. There is no electric force experienced by the droplet. So the free body diagram appears something like this. This is the point which represents the droplet. It has got mass m. Okay, it experiences gravitational force which acts in the downward direction. The gravitational force. The buoyant force which is due to the upthrust, acts in the opposite direction of the gravitational force. This is the buoyant force, FB, acting in the upward direction. Now, along with this, one more force acts. That's nothing but the viscous force. The viscous force also acts in the upward direction. So, viscous force along with buoyant force balances the gravitational force. Okay. So, this is the free body diagram of the system in the absence of electric field. Okay. So first I'll find out the radius of droplet. Radius of the oil drop. Radius of the oil drop. Here I assume that the drop is spherical in shape. Okay, the spherical shaped drop is moving only under the action of gravity in the absence of electric field or in the absence of electric force. Then, apart from gravitational force, it experiences more two forces, which are nothing but buoyant force and a viscous force. See here. To get the expression for gravitational force, I start with the equation of density. Now, density, which is usually represented by letter rho. Here, rho is the density of oil. Okay, rho is the density of oil. The density is the ratio of mass and volume. If you divide mass with volume, you obtain density. Here, capital V stands for volume. Okay, and I told you earlier, I assume that the oil drop is spherical in shape. So, the formula of volume, the formula used to determine the volume of a sphere is nothing but 4 by 3 pi r cube. That right somewhere here. V is equal to 4 by 3 pi r cube. Here r is the radius of the oil drop. Okay. Actually, I am going to find out the expression for r only. Okay. That I will substitute here. Actually, here my aim is to get the value of m. So, I'll write this. Now I am going to cross multiply this to get the value of v. So when v goes that side, it will actually I am going to get the value of m. I take v that side, so it will multiply and I obtain the value of m. Okay, and here I am going to substitute the value of v. So m will be equal to rho multiplied with 4 by 3 pi r cube. This is the expression of m, mass of the oil drop. I take this as equation number 1. Okay. Now, my aim is to get the expression of Fg. So, for that, we know very well gravitational force is the product of mass and acceleration due to gravity. Okay. Fg is nothing but mass multiplied with acceleration due to gravity. Here g is acceleration due to gravity. We know the value of m that I am going to substitute here. I take this equation number 2. Substituting 1 in a 2. Substituting 1 in a 2. So what I'll get? I get this. I get Fg to be equal to the value of m is this. This rho is 4 by 3 pi r cube. Okay. Instead of writing g here, I write g beside a rho. Okay. This is equation number 3, and it represents the gravitational force. Okay, I'll box this for better visibility. This is the gravitational force. Now I'm going to get the expression for buoyant force. Then I'll move to viscous force. Okay. Now the expression for buoyant force is written similar to this. Here, buoyant force is due to the presence of air inside the chamber. Actually, when drops are moving downward due to gravitational force, the presence of air in the surrounding tries to oppose the motion of the droplet. So, an upthrust force is acting in the opposite direction of the motion of the droplet. Okay, that is why buoyant force always is shown by an arrow mark, which acts exactly opposite to gravitational force. So here, buoyant force FB is due to air. So what I'll do here, I'm going to replace rho with a sigma. Here sigma is the density of air. Sigma is the density of air. So the remaining things are written as such. G multiplied 4 pi 3 pi r cube. I take this as equation number 4. This is equation number 4. Before I go ahead, I'm going to box this for better visibility. Okay. This. We got the two equations, equation number 3 and equation number 4. Equation number 3 represents the gravitational force, whereas equation number 4 represents a buoyant force. Now, by keeping this free body diagram in mind, I'm going to balance these equations. I'm going to balance these forces. Here, according to the diagram, Fg is equal to the sum of Fb and Fv. Here F is viscous force. No, I don't know the value of, I haven't mentioned the value of Fv that I am going to mention here. Now before that, I will name this equation as equation number 5. Now here, viscous force, the expression for viscous force is obtained from Stokes' law. What is the Stokes' law? What does it say? Now we have studied about Stokes' law in 11th physics. Stokes' law says that viscous force is given by equation 6 pi r eta v. Here v is a small v. Here small v stands for terminal velocity. What is that? That I'll tell you. I'll tell you about the terminal velocity later. Here r is the radius of the drop. Eta is coefficient of viscosity, and v, as I told you, is nothing but terminal velocity. This is equation number 6. Now listen to me carefully. Here, when a drop starts moving downward due to gravitational force, in the presence of air, it experiences air drag. As a result, the velocity of the drop decreases as it moves downward. At one point, drop starts moving with a constant velocity. We call that constant velocity as terminal velocity. Clear? I hope you have understood. Now, I'm going to substitute equation number 3, 4 and 6 in equation number 5. Substituting 3, 4, 6 in 5. In equation number 5. So what I'll get if I do so, I get this. Fg, nothing but rho g multiplied with 4 by 3 pi r cube is equal to, here Fb value is rho g multiplied with 4 by 3 pi r cube, and here in the place of Fv I write this equation number 6 pi r eta v. So this is what I have. Now I'll take this term to the left hand side. So by doing so, what happens? Now this positive term becomes a negative. So it is taken to the left hand side. So here I'm going to reduce one step. See, okay. Let me elaborate. Write this. Let us take on this side. I'm not going to reduce one step. Instead, I will go. I'm going to increase one step here for a better understanding. Okay. Now, if you look at these two terms, they have got a common term. 4 by 3 pi r cube is common here. Even g is common. So, the common term is taken out. G 4 by 3 pi r cube. This is the common term. It's written in bracket. So outside what we have? We have this rho minus a sigma. Okay, this is what remains here. Okay, is equal to 6 pi r eta v. So see, I will cancel equal terms. Present both sides. Here pi, this side pi will cancel. What else? This r. Here we have r cube. On cancelling this, we get a r square. Okay. So you should not forget that our aim is to get the expression for radius of the oil drop, which is represented by letter small r. Okay. Here I have r square, so it is alone kept here. Remaining things are taken to that side. So r square is kept here. Remaining things are taken to the other side. So here I have 6 eta v. 6 eta v. Small v. Okay. Just to differentiate, I use a curl here. Then G along with 4 comes down to the denominator. Okay. Then along with that, rho minus sigma also comes down to the denominator. Then what is left here is nothing but 3. 3 is already in denominator. When it is taken to the other side, it will multiply. It will multiply. Okay. 3, 6 are 18. Okay. So here I get r square is equal to 18 eta v divided by 4 g rho minus sigma. Okay. The next here we have 2 2's in 4. There are 9 2's are present in 18. Okay. Then the next step, I write this r square is equal to 9 eta v upon 2g multiplied with rho minus sigma. This is the expression of r square. Now, my aim is to get the value of r, but what I have obtained is the expression for r square. So, r value can be obtained by taking square root. The square root of r square is r, and here the place of square root, right? I raise it to power half. Okay, we know very well. We know that root of x can be done as x power half. By keeping that in mind, instead of taking root here, I raised it to the power half. Okay, I'll box this. I'll box this. Okay, I name this as equation number 7. This is equation number 7. Equation number equation number 7. Okay, so we obtained the expression for radius of the oil drop. Now using this expression, equation number 7, I am going to get the expression for the charge of the drop. Now I will determine the charge of the drop. The title is determination of the charge on a drop. Now, to charge these drops, X-ray is passed through one of the windows. When you pass X-rays, we know X-ray is nothing but an ionizing radiation. When it passes through a gas or air, it ionizes them. So, the air present inside the chamber gets ionized when it experiences, when it come across with the X-rays. When you pass X-ray, the air present inside gets ionized, and these drops attracts the charges from those ions. They occur charges. Suppose Q is the charge occurred by these drops. Then electric field is produced here by connecting high tension battery to these discs. I told you we pass 10,000 volt across these discs. As a result, a strong electric field is produced here. In the presence of this electric field, the charged drops can be moved upward, they can be moved downward, and they can be made to stop at one place for a long time, such that they can be observed clearly with the help of a microscope. Okay, that's what we do. So here we ionized the air present inside by passing X-rays. As a result, these drops occurs charge. Then, due to the presence of electric field, they move upward, downward, or they can be stopped. Okay, we stop one charged droplet here, and we observe the help of a microscope. So, in the presence of electric field, now the droplet, which is represented by this point having mass m, experiences a force in the downward direction. That force is nothing but gravitational force, due to which it moves downward. Then there is one more force here acting on the droplet, that is buoyant force. That's similar to this. Now, viscous force is replaced here with the electric force, a new force. What is that? This electric force. So gravitational force balances buoyant force and the electric force in this case. Suppose I say that the droplet is at rest. It means it is balanced by the gravitational force and the sum of these two forces. So the net force is written as Fg is equal to the sum of remaining forces, Fb plus Fe. Here the expression for gravitational force is rho g multiplied with 4 by 3 pi r cube. That we have already derived earlier. On this side, the expression for buoyant force is sigma g multiplied with 4 by 3 pi r cube, and electric force is the product of electric field and charge present on the droplet. Okay, this is the expression. Now my aim is to get the expression for Q. So what I'll do, I'll take this term to the other side. So by doing so, what happened? Only EQ remain here. EQ remain here. Remaining things will go that side. So G multiplied with 4 by 3 pi r cube. This positive term when taken to the other side become negative. Okay. Sigma G multiplied with 4 by 3 pi r cube. Okay. Now I simplify this. That EQ with this side. As such, the common terms are taken. One side, what is that? G 4 by 3 pi r cube is common in both. Then what remains is nothing but this, rho minus sigma. Okay, then both sides, what is the common term? Nothing. Nothing is common here. So I keep only Q here, this side, and E is brought this side, the other side. So if I do so, what I get this. You see, G rho minus sigma. Okay, pi is present in the numerator. What is present in the denominator is 3. Is 3. So this 3 we multiply with the E. The one thing I didn't mention here is 4. So 4 is left here in the numerator. Okay. So there is one more term that I haven't mentioned here. There is nothing but r cube. So I open a bracket here. Outside the bracket I write r cube. Okay. I take this as equation number 8. This is equation number 8. Okay. Now I'm going to substitute the value of r from equation number 7 in equation number 8. Let's see what I get if I do so. Yeah. Q is equal to 4G multiplied with rho minus sigma multiplied with pi divided by 3 capital E. Here, the place of r cube, the place of r I write its value. That's nothing but this 9 eta V divided by 2G rho minus sigma. Okay, already power half is present here, and here we have 3 with half. We obtain 3 by 2. What do you get? 3 by 2. Power 3 by 2. So it is raised to the power 3 upon 2. Okay. So here, now before I go ahead to the next step, I would like to explain some simple basic things, basic mathematical operation. What is that? Suppose I have x raised to power 3 by 2. Then this can be written as x multiplied with x power half. Here when nothing is present in the power, that means the power is 1. Is equal to x power 1. Okay. So here this can be when you multiply these two, you get x power 1 plus half. Yeah, 1 plus half. How will you add 1 with the half? 1 with half can be added by taking LCM. You need to take LCM. Here see, the denominator is nothing. That means the denominator is equal to 1. So this can be as 1 by 1 plus 1 upon 2. Okay. Now to add these two, number, we must have same denominator. So both must have denominator to be equal to 2. Otherwise we cannot able to add them. So to turn 1 into 2, what I do? I multiply this with 2. I multiply this with 2. When I make any changes to denominator, the same thing has to be done with the numerator. So I multiply numerator with 2 as well, plus half. Now see what I get. Next step, 2 multiplied with 1 is 2, 2 by 1 is 2, plus 1 by 2. Then you see, denominator is common, both are 2. So I take the common denominator. Then what is left here is added up. So 1 plus half is equal to 3 by 2. Okay, I hope I have understood that why it is 3 by 2 when I add 1 with half. Okay, so this I'm going to use this step here and to simplify this one. Yeah. So I take Q equals to 4G rho minus sigma multiplied with pi divided by 3E. Okay, and here I expand this. How do I expand it? It is expanded as 9 eta V divided by 2G multiplied with rho minus sigma. Okay, so when the power is nothing, it means power is 1. This side the same I write 9 eta V divided by 2G rho minus sigma. Okay, and it is raised to power half. Is raised to power half. Is raised to power half. Okay, I have drawn a line here to separate these two parts, so they should not get a confusion. Okay, now based on this equation I have expanded them. Okay, now I will cancel similar terms. You see, rho minus sigma is getting cancelled with this. Then do we have any other similar terms? Yes, G and G also get cancelled. Then what else? That's all. Then I'll take the remaining terms. Q is equal to 4. Okay, here I can cancel 2. 2, this 2. Oh, this 2. So I get a 2 here. This 2 multiplied with the 9. This 9. Then what is left here is pi. Pi here is eta v. Then there's nothing in the denominator. Yeah. No, but here is 3. 3e is left here. 3. Okay. Now you can simplify this further. 3. How many 3s are here? 3. 3 3s are represented in 9. Okay. And what is left here is this 9 eta v divided by 2g rho minus sigma raised to power half. Okay, raised to power half. Correct? The next is cube. Now I bring a 9 outside. So root of 9 is 3. And so here already 3 is present. 3 pi upon e right here. Then eta v is written outside the bracket. Then this side, I write this as such. The next step will make a necessary change. Now eta v 2g rho minus sigma power half. Next, this can be written as q equals to, here 2 multiplied with 3 gives us 6 pi eta v. So here 9 raised to power half gives us 3. Root of 9 is 3. When I bring that 3 outside, it gets multiplied with the 6. Now that I am going to write in the next step is a e here. Okay. Here I bring the power of 9 outside. Root of 9 outside, just nothing but 3. Okay, so what is left inside is eta v divided by 2g multiplied with rho minus sigma raised to power half. Okay, now here I am going to multiply 3 with 6. It gives us 18 pi divided by e. I write eta v outside. Eta v is written outside, no, within bracket. And here what do we have is nothing but eta v divided by 2g rho minus sigma raised to power half. Okay. Now look at this carefully. What changes I'm going to make? I'm going to use a simple trick here to simplify this final expression. What is that? See? Eta q such 18 pi upon e. Here instead of eta v, now I write eta square v square. Then I raise it to power half. Okay, then this one, this written as this term eta v divided by 2g rho minus sigma. Okay, and it is raised to power half. It is raised to power half. It is raised to power half. Now, these two parts have got the same power, which is nothing but half. Now, when I take it inside, eta square will multiply with eta and will give us eta cube. In the similar way, v square will multiply with v will give us v cube. How I can able to do it? I can able to do it because both of them have got the same power. Okay, both of them have raised to the same power. That's why I couldn't able to do it. Otherwise, it is not possible to do. So the next step, Q equals to Q is the charge present on the droplet is equal to 18 pi divided by E, that this term goes inside and gives us this eta square with eta cube, v square multiplied with v gives us v cube divided by 2g rho minus sigma. Okay, the whole term is raised to power half. This is the final expression which gives us the expression of Q. Okay, I name this as equation number 9. This is equation number 9. Okay, Millikan repeated this experiment several times. While performing this experiment, he repeated this several times, and every time he found that the value he obtained is an integral multiple of a common term. That common term had a value to be equal to minus 1.6 10 power minus 19 coulomb. This is the common term that he obtained every time he repeated the experiment. Okay, and this value is nothing but the charge of electron. Okay, the fundamental value, the charge of electron. This is how Millikan can able to obtain the charge of electron using this experiment. I hope the video is useful. If you have any kind of doubt relevant to the topic, can you put your questions in the comment section. Thanks for watching.